So Avantika, what we will discuss is we'll discuss basically three things. The first thing that we will discuss is that till class 10th, our definition of angles was limited to the first quadrant. Our
Yeah.
angles were from 0 degree to 90 degree.
Hmm.
Now, so for defining this angles from 0 to 90, what we used was a right triangle.
Hmm.
And this used to be the theta, and this theta used to move from 0 to 90. That was the limit.
Hmm.
So now we need to extend the values of theta from 0 to 360 and beyond.
Hmm.
In the last few lectures, what we have understood is that 360 degree is equal to 720 degree is equal to so on. So
Hmm.
what we have understood is that yes, angles are not limited to 0 to 90. They can
Yeah.
go beyond. They can go beyond 360 degree. They can go beyond 720, whatever degree that you want. And we have also learned the another measure of angle, which is the radians.
Hmm.
But now we want to define that if there is something called sine 225 degree, what does it mean? What does sine 225 means? So this is the first thing that we'll be doing. We'll be extending the definition of theta.
Hmm.
First, our theta was defined in a right triangle. Now, what we want to do is we want to extend the definition of theta to any angle. So this is the first thing that we'll do.
Okay.
We'll understand what are the signs of sine, cos, tan, cosecant, secant, cot in the four quadrants.
Okay.
In, in some quadrants, sine would be positive, and in the other it will be negative. We'll try to understand where sine is positive and negative, where cos is positive and negative, where
Hmm.
tan is positive and negative. And one thing is pretty obvious, and if it is not obvious, I'll let you know. So, for example, in one of the quadrants, say sine is negative. Now, if sine is negative, of course, cosecant would also be negative.
Hmm.
So when I say, for example, that in the second quadrant sine is positive, it means sine and cosecant both are positive.
Hmm.
And
Okay.
what this means is that secant, cos, tan, cot, these four would be negative. Have you understood the logic?
Okay. Yeah.
So don't worry, we'll discuss this in detail, but this is the second point that we'll be covering in this lecture.
Hmm.
So we'll also understand the meaning of this mnemonic. All science teachers are crazy. And if you don't like this, another one is after school to college. After school, after school to college. So we'll understand these two mnemonics. What do they mean?
Okay.
The third point that we'll be covering would be we'll try to understand. Of course, what we will try to understand is that the values of sine, cos, tan, cot, secant,
Hmm.
cosecant in the four quadrants. So 0, 30, 45, 60, 150, 180, 210, 300, 330. So we'll try to
Hmm.
understand this table. What is the meaning of this table and how do we get these values?
Hmm.
Now, for getting these values, we'll be using this unit circle,
Hmm.
and we'll understand the logic of this unit circle. Once we understand the logic, then this table will become very easy for us. Okay.
Okay.
Once we have done this, then we'll move on to the fourth point. Actually, this would be the fourth point. The fourth point that we will be discussing would be the values of the trigonometric functions when they are negative. So, for example, what we will try to understand is what is tan minus theta, what is secant minus theta, what is the relation of sine minus theta,
Hmm.
and sine theta. What is the relation? What is the relation between
Okay.
cos minus theta and cos theta? So,
Okay.
this is the fourth point that we'll be covering.
Hmm.
So this is the third point, trigonometric functions of specific angles. The specific angles are these angles, 30, 45, 60. So in
Hmm.
class For example, in class 10th, what you used to focus was only on these angles 0, 30, 45, 60, 90, and rest of the angles. For rest of the angles, we used to so for rest of the angles. So for example, if I ask you sine of 25 degree, then they used to give you a table in the end of the textbook. There used to be this
Mm-hmm.
sine, cos, tan table there. You could refer the values. So
Yes.
let us first understand the first point. Let us extend the value, let us extend the definition of theta. Now,
Okay.
this is how the definition of theta will get extended. What we'll say is that there is a, what we'll say is that there is a circle like this,
Mm.
and on this circle, so this is the radius r,
Yeah.
on this circle, this is a point x, y, any random point. Do
Mm-hmm.
we have any doubt till here?
No.
No. Now, we know from basic coordinate geometry that this distance this distance would be x and this
Mm.
distance would be y. Are we
Mm.
comfortable today?
Yeah.
See, this is the same like saying that in the coordinate system, if you take any random point xy,
Mm-hmm.
then this is x
Mm.
and this is y.
Yeah.
All I'm saying is that you take this xy, the coordinate
Mm.
system is the same. The coordinate
Mm-hmm.
system is the same. So this is the x-axis, this is the y-axis. So
Mm.
from the origin 0, 0, I draw a circle of radius r. And then if I take any point on that circle xy in the first quadrant, the point would be x comma y. So x
Yeah.
would be the base and y would be the
Mm-hmm.
perpendicular. Now this
Yeah.
angle theta, see, so if this is OAB, then this OAB triangle is a right triangle, and
Mm.
this triangle is the same which we use to define our sine cos tan in class 10th. So if I ask you this is theta and I ask you this is x, y, this is r. So if I ask you what will be r, you will say this will be x square plus y square. Any doubt in it?
Yeah. No.
Any doubt in it? Okay.
No.
Now one thing that you need to observe is uh, that this r, the value of r, because
Mm.
this is the radius, this
Mm.
value of r will never be negative. Have you understood?
Okay. Yeah.
R will always be positive. What I
Okay.
mean by this is, what I mean by this is that if the point B comes here,
Mm.
it becomes B dash. Now, if you see, this would be negative x and this would be positive y. Dash would be defined as minus x comma y.
Yeah.
Any doubt?
No.
But the value of r would remain x square plus y square. Do you see that?
Okay. Yeah.
Similarly, if my b comes here, so this would be b double dash.
Mm.
My x is negative, my x is negative, my x is
Mm-hmm.
negative, and my y has also become negative. Do you see that?
Mm. Yeah.
So this point b dash is basically minus x comma minus y,
Yeah.
but my radius remains positive. Do you see that?
Yeah.
And similarly, if my b comes to the fourth quadrant,
Mm-hmm.
again my x becomes positive, but my y
Mm.
becomes negative. Do you see that?
Yeah. Yeah.
But my radius remains positive. Do you see?
Positive. Yeah.
So basically, what I'm trying to tell you is that now what I'll do is, as I want to extend the definition of theta, what I'll do is, I'll say, I'll say that my theta is defined with the help of this point xy,
Mm.
and this point xy is at a distance r from the origin 0, 0,
Hmm.
where r is root of x square plus y square. Whatever angle this theta, whatever angle this radius r
Hmm.
makes with the positive direction of x-axis would be my theta. Any doubt till there?
No.
And I give freedom to this radius to go in any quadrant. So I give
Hmm.
freedom to this radius that it can move in the first quadrant, it can move in the
Hmm.
second quadrant, it can
Hmm.
move in the third quadrant, it can move in the fourth quadrant. And so, for example, if my radius moves to the fourth quadrant,
Hmm.
the theta would be the angle the radius is making with the positive direction of the x-axis. Any
Yeah.
doubt here?
No.
If my radius goes to the if my radius goes to the third quadrant, again
Hmm.
the angle that this radius would be making with the positive direction of x-axis is my theta.
Hmm.
Any doubt here?
No.
If my radius comes to the second quadrant,
Hmm.
again my theta would be the angle that this radius is making with the positive direction of x-axis. So
Hmm.
now if you see, if you have observed, what I have done is from the theta which was confined to the right triangle, where theta could take only take values from 0 to 90, with the
Hmm.
help of a circle, what I have
Hmm.
done is I have let my theta move anywhere in the first, second, third, fourth quadrant. Do you understand? Have you
Yeah.
understood what I'm saying? Okay.
Yeah.
Now another thing that will start happening is, and always remember that my radius will remain the same. So in
Hmm.
this right
Okay.
triangle, always remember this would remain the same.
Hmm.
This would remain positive. But the
Yeah.
values of x and y, as per whether they are in the first quadrant, x, y both would be positive.
Hmm.
In the third quadrant, both x and y would be negative.
Yeah.
But radius would remain the same. And if I am defining the radius in terms of the right triangle, then the radius is the hypotenuse of the right triangle. So
Yeah.
therefore, the hypotenuse would remain positive. Any
Okay.
doubt here?
No.
Now all that I need to do is I need to say that my sine theta is again this y perpendicular upon hypotenuse. This cos theta is my base upon hypotenuse. My tan theta is this upon this.
Okay.
Avantika, have you understood till here? Any doubt till here?
No.
But one thing which has happened now is that once you define your sine theta as
Hmm.
y upon r, your cos theta as x upon r, your tan theta as y upon x. Now we have left the shackles of the base, the perpendicular, etc. Because now wherever y is, that is what will help us define our sine theta. Wherever
Hmm.
x is, it will define us our cos theta. Wherever
Hmm.
y and x is, they will help us define tan theta. What
Yeah.
do I mean by this is, so for example, if my theta comes here, so for example, this is say minus 5 comma 4. If this is minus 5 by 4, now see how I am able to extend the definition of theta. X is minus 5 and y is 4. Let me clearly write like this. My r would be minus 5 square plus 4 square is equal to root 41. Avantika, are we
Hmm.
okay?
Yeah.
And now our lives becomes very simpler because sine theta, cos theta, tan theta has been defined in terms of y and x. And you will see how our life becomes easier because sine theta is perpendicular upon R. But now see that definition remains the same. It is perpendicular upon hypotenuse. But we speak it in terms of y upon r. And we write cos theta as x upon r. And we write tan theta upon y upon x. Have you understood the logic, Avantika?
Yeah.
So now this y is 4 upon 4 upon root 41. My cos theta is minus 5 upon root 41. My tan theta is upon 4 upon minus.
-5.
And similarly, I can write the values of cosecant theta, secant theta, cot theta, minus 5 upon 4. And if you observe, this is what we were discussing in the beginning of the lecture, that the signs of sine and cosecant, of cos and secant, and tan and cot would remain the same. Do you see that?
Yeah.
So if sine is positive, cosecant is positive. If cos is negative, then secant is negative. If tan is positive, negative, then cot is. If tan is negative, cot also is negative. Any doubt till here?
No.
Now, this minus 5 by 4, this minus 5 by 4, let us play with the minus 5 by 4 only. So if this minus 5 by 4, let us assume that this minus 5 by 4 comes to the third quadrant. In third quadrant, this will become minus 5 comma minus 4. Any doubt?
-4.
Any
No.
doubt? So again, if I do sine theta, cos theta, tan theta for this minus 5 by 4, because sine theta here, the only change that has happened is that now my x is minus 5 and my y is minus 4. Do you see that?
Hmm.
See, the only thing that has happened is that the signs have changed. And
Yep.
now, but how do the the trigonometric ratios get affected? That you'll see in just a minute. That sine theta now is y upon r. So my y is minus 4 and my r would remain positive, root
Hmm.
40. So cos
Yeah.
theta is x upon r. X is minus 5 upon
Hmm.
root 41. Tan is y upon x. Y is minus 4
Hmm.
and my x is.
-5.
Now, if you see, your sine has become negative, your cos is negative, but your tan has become positive. Do you see?
Positive.
Do you
Yeah.
see? In this quadrant, in the second quadrant, in the second quadrant, your
Hmm.
sine was positive,
Hmm.
your cos was negative, and your tan was negative. Do you see that?
Hmm. Yeah.
Okay. Now let us bring this minus 5, 4 to the third quadrant. Let us play with this only. Uh, so I bring this to the fourth quadrant. So this will be 5 and this would be minus 4. Any doubt, Avantika?
No.
This is my second quadrant. This is my third quadrant. And now I will discuss my fourth quadrant. Fourth quadrant.
Okay.
So again, sine cos tan has now been defined just in the form of x, y, and r. That is the big thing that I've done. Because once I define my sine cos tan in terms of x, y, and r, then I just have to track my, which quadrant I am to just see the value, just see whether it is positive or negative. So
Okay.
sine is defined as y by r. This is my x, this is my y. So sine theta is y upon r. So this would be minus 4, minus 4
Hmm.
upon r.
241.
Cos is x upon r, so this would be 5 upon root 41.
Hmm.
Tan is y upon x,
Hmm.
minus 4 upon 5. Now, if you see the signs,
Hmm.
your cos is a negative. I'm sorry, your sine is
Sine
negative,
is negative.
your cos is positive, and your tan
Hmm.
is negative. Do you see
Yeah.
this?
Yeah.
So, just to remember,
Hmm.
we have this mnemonic ASTC.
Hmm.
All science teachers are crazy. What
Hmm.
this means is that sine, cos, tan, all are positive.
Hmm.
Only sine and cosecant are positive. The rest,
Okay.
secant, cos, tan, cot are negative. Any doubt? Avantika, any doubt?
No.
Here only tan and his brother cot, they are positive.
Hmm.
Sine, cosecant, cos, secant are negative.
Hmm.
Crazy. Cos, secant are positive.
Okay.
Sine, cosecant, tan, cot
Negative.
are negative.
Okay.
Any doubt?
No.
So now they'll ask you, just for practice, I'll be giving you a few questions. So all that you need to remember is, for example, they'll ask you, let us assume, okay, let me do a few examples. So for example, they'll ask you uh, 245 degree, or they'll ask you 325 degree. Tell us the sign, this sign, the sign of sine, cos, tan. Have you understood the question?
Okay. Yeah.
So all that you need to understand is that in which quadrant is 245. 245 degrees in which quadrant, Miss Avantika?
245 would be third.
Third quadrant. So in third quadrant, which is positive?
Third quadrant. Wait. Third quadrant. Oh, none. Okay. I'm confused. 1 second.
Yeah, no problem.
Only tan is positive.
Yeah. Only tan is positive.
Yeah.
Yeah. So only tan is positive.
Hmm.
So sine and cos would be negative.
Negative.
Any doubt?
No.
No, it's pretty easy. We'll just do 3 4 question and you'll understand.
Hmm.
325 degrees in which quadrant?
Fourth.
Fourth quadrant.
Yeah.
So only one would be positive.
Cos.
Cos. So only cos would be positive. The rest
Hmm.
would be negative.
Yeah.
Any doubt?
No.
Okay. Now let us say 540 degrees. So 540 degrees, can you tell me in which quadrant it will be?
542.
Or
1 second.
let us assume 550 degrees.
Okay. Third quadrant.
550 minus 360, 9431. So this will be in third
Third
quadrant.
quadrant.
In
Yeah.
third quadrant, which is positive?
Uh, Positive is tan.
So only tan would be positive,
Hmm.
sine and cos would be negative. Any doubt?
Yeah. No.
And of course, this implies is that cot would also be positive, and cosecant and secant would also be negative. Any doubts, Navantika?
Hmm. No.
So we till now we have done two things. One is we have extended the value we have done extended the value of cos and sine. Are you okay?
Yeah.
Any doubt?
No.
So this is what we did. We defined the value of cos as x by r. We defined the value of sine as y by r.
Yeah.
Yeah. And using this, we can define the value of tan as y upon
Bye
x.
bye.
Any doubt till here?
No.
So this is the first thing that we have done. Yeah.
Hmm.
The second thing that we have done is we have understood the signs of the trigonometric functions in different
Yeah.
quadrants. And we have two mnemonics. One is all science teachers are crazy. The other one is after school, after school to
College.
college. Yeah. So whichever you prefer, you can remember. There are other mnemonics also in the market. A lot of mnemonics are there. Okay. Uh, once we have done this, once we have done this, then we need to understand the trigonometric functions of specific angles. What do I mean by specific angles? Specific angles would be, angles like 0, 30, 45, 60. So these are the specific angles. For that, I require the help of this. This is what is called a unit circle. Unit circle.
Okay.
Unit circle. Why do they call this a unit circle? They call this a unit circle because the radius of this circle is 1. Have you understood what I'm saying?
Yeah.
See, we now define our theta using this circle. Now, what I am saying is that if you make this radius of this circle to be 1, this would be called a unit circle. That is it. It is the same
Okay.
circle that I have used before. Any doubt?
No.
So, this circle. So, what is a unit? A unit is 1. It can be 1 meter, it can be 1 centimeter, it can be 1 kilometer. All that I want is that I need a circle whose radius is 1. That is it. Just make this 1 unit. Any doubt?
No.
Okay. Now, once I have defined this to be units radius, then what I have understood is that if this is xy, then what I understand is that x square plus y square would be equal to 1 square. Any doubt?
No.
Yeah. So this is all that is the meaning of a unit circle. Are we okay till here?
Yeah.
Okay. Now what we'll do is, now what we'll do is, because from class 9th, class 10th, what we have been focusing more, because these are the values which have been told to us, we are focusing more on 0, 30, 45, 60, 90. These are the values that we focus more.
Yeah.
So this is what we will do in this unit circle also. And how do we do that? This is how we do. So I'll explain you the logic for the first and the third quadrant. The second and fourth quadrant would become very easy. So, uh, yeah, I think more or less we are almost. Okay, let me redraw this. Yeah, this seems to be more like 30 degree. This seems to be more like 60 degrees. And this seems to be, yeah, I think more or less it is fine. So, this is 30 degrees. This is 45 degrees. And this is 60 degrees. Are we okay till here?
Yeah.
This is a unit circle. Remember, this is a unit circle. The radius is 1 unit. Yeah. Okay. Now, I'll require a few more lines. So let me draw those lines. This is what we had done last time also,
Hmm.
but the values that we had put in the last lecture were some crazy numbers.
Hmm.
So basically this is the same figure that we had drawn last time,
Yeah.
but the values would be correct this time. Okay. Okay. So yeah, more or less this is right. Yeah. So now this is my, if you focus on O, let me call this PQ. If you focus on triangle OPQ, it is a right triangle. It is a right triangle.
Hmm.
Now my sine theta has been defined as y upon r.
Yeah.
My cos theta has been defined as x upon r.
Yeah.
My tan theta has been defined as y upon x.
Hmm.
Therefore, my y would be r sine theta. Have you understood the logic?
Yeah.
And because this is a unit circle, my r is 1. This is why what I
Hmm.
have written here. And
Yeah.
therefore, my y would be sine theta. Have you understood?
Yeah.
Similarly, if you have got the logic, x is equal to r cos theta. R
Hmm.
is 1, therefore x is equal to cos theta.
Hmm.
Any doubt is there?
No.
Okay. So the point that I'm trying to make is that this point Q
Hmm.
is basically, if this angle is 30 degree,
Hmm.
then this point Q is xy and
Yeah.
x is equal to cos theta. So point Q is basically cos theta, comma sin theta. Any doubt?
No.
And because theta is 30 degree, this would be cos 30 degree and sin 30 degree. Any doubt?
No.
Can you tell me the value of cos 30?
Cos 30 is root 3 upon 2.
Root 3 upon 2. Can you tell me the value of sin 30?
Sin 30 is 1 upon
1 upon
2.
1 upon 2. Okay. So the point is that is this value is root 3 by 2 comma half. Any doubt in here?
2. No.
Now, like I have defined Q, I can also define, let us, if this is OPQ, let me take this as, let me change the color. Let me say this is OAB
Okay.
and this be OCD. Have you understood what I've done?
Mm-hmm.
Yeah. So
Yes.
my B would
Hmm.
be cos 60 comma sin 60. Have you understood what I've done?
That'd be B, right? You're doing 45,
It will be
right?
45 degree. Yeah. Thank you.
Yes.
Thank you. So this will be cos 45
Hmm.
sin 45
Yeah.
and this would be D would be cos 60 comma
Sin
sin 60.
60.
Are we okay
Hmm.
till here?
Yeah.
And then I have to just put the value. Values
Hmm.
of cos 45 sin 45 are easy. This would be 1 comma root 2. This would be 1 comma root 2. Any doubt?
Hmm. No.
And cos 60 would be half
Hmm.
because cos 60 is sin 30. So this would be half. And sin 60 is cos 30. So this would be root 3 by 2.
3
Am I
upon 2.
correct?
Yeah.
Okay. So, and if you see here, this is 0 degree. So
Hmm.
this would be 1 comma 0. Why? Because it is cos 0 comma
Hmm.
sin 0. Any doubt?
No.
Any doubt, Avantika?
No.
Again, this would be cos 90. Cos 90 is 0. and sine 90 is 1. Any doubt,
One.
Avanti?
No.
So the values that I have that were told to me in terms of the triangle, now
Hmm.
I know these values in terms of a unit circle. Have you understood what I've said?
Yeah.
Now, slowly you will start appreciating the power of this unit circle.
Mm-hmm.
One thing, so for example, my q is root 3 by 2 comma half.
Hmm.
Now, if you have understood this is x, this is y, and my
Hmm.
x square plus y square is equal to r square, in this case
Hmm.
r is 1. So is my x square plus y square is equal to 1? Let me check. So root 3 by 2 square
Hmm.
plus half square is equal to 3 by 4 plus 1 by 4 is equal to 1. Have you understood?
Yeah.
So what I'm trying to tell you is that you take square of all these 1 square plus 0 square under root is 1.
Mm-hmm.
1 by root 2 square plus 1 by root 2 square under root would be 1. 1 upon 2 whole square plus root 3 by 2 square ka under root would be 1. Have you
Hmm.
understood the logic?
Yeah.
Because this would be applicable everywhere. This would be applicable everywhere. Are we
Hmm.
comfortable till here?
Yeah.
If we are comfortable till here, then all that you need to do is once you have these, 1, 2, 3, 4, 5 values, then rest of
Hmm.
the unit circle becomes very easy. Why it becomes easy? Because all that I need to do is 1 comma 0, this point will become minus 1 comma 0. Any doubt?
Hmm. No.
If this is root 3 by 2 half, this will become, can you tell me?
1 second. So which is this? This is your root 3 by half is
Yeah, Q, if this is Q point,
for
and I want
30.
to track this Q as Q dash here, can you tell me the
Mm-hmm.
coordinates of Q dash?
It would be minus root 3 upon 2, uh, 1 by 2.
Shabash,
Positive y.
shabash. It will be minus root 3 by 2, comma
1 by 2.
1 by 2. Shabash. And to extend this further, I can take this here.
Hmm.
Now, can you tell me the value?
Minus root 3 by 2 and minus 1 by 2.
Have you understood the logic?
Yeah.
I can bring my Q double dash to here. Here. Can you tell
Mm-hmm.
me the coordinates of this point? Q triple dash
Uh, root 3 by 2 minus 1 upon 2.
minus 1 upon 2. Shabash. Any doubt till there?
No.
Yeah. Now, see, slowly you'll start appreciating the power of this unit circle.
Mm-hmm.
So this is 30 degree. Yeah.
Mm. Yeah.
From here to here is 180 degree. I repeat, from here to here is
Mm-hmm.
180. Have you understood the logic?
Yeah.
So therefore, from here to here would be 210 degree. Any doubt?
Hmm. No.
Any doubt?
No.
So what we need to remember is that if this line, just understand the logic. If this line
Hmm.
is 30, then this
Hmm.
line is 180 plus 30. Any doubt?
No.
If this line is 40, then this
Hmm.
line is 180 plus 45.
Hmm.
Any doubt?
No.
If this line is 60, this line would be 180 plus 60. Any doubt?
Yeah. No.
So basically, what I can write here as 210 degree. I can write here as 240 degree,
225.
225. Yeah, absolutely correct. 225 degree.
Hmm.
And this would
240.
be 240 degree. I'm already aware that this is 270 degree.
270.
I'm
Hmm.
already aware that this is 180 degree. Any doubt?
No.
Do you do you see how powerful this unit circle is? You can see
Hmm.
all the values with the help of this unit circle.
Yeah.
Any doubt till here?
No.
Yeah. And you can use basic geometry. And in the previous lecture that I had said you, I had proved this also. But now you just need to trust me.
Hmm.
This is 30 degree. You just need to
Hmm.
trust me. If you want the details, you can relook at the the previous lecture. I
Hmm.
don't want to make this lecture as long as that previous lecture. But the logically what you'll be able to see now is this line OQ dash is basically 150 degrees. Any doubt in it?
No.
This line, this BB dash,
135.
I'm sorry.
I'm sorry. If you're going to the other one, it would be 135
Yeah,
degree.
basically this will be 180 minus 45.
Minus 45. Yeah. Understood
This
that.
will be 135 degree.
Hmm.
135 degree.
5.
135 degree.
Hmm.
And this would be, can you tell me what this would be?
120.
Shabash. 120. Any doubt?
No.
Okay. Now we'll take the help of the what we had done before, and what I'll do is I'll extend this line to here, and this line to here, and this line to here,
Hmm.
approximately. Uh, Let me do it like this to here. You would have understood the logic.
Yeah.
So this will become, because this is a rough drawing, that is why they are not matching. But this is a straight
Yeah.
line. So
Not a.
120.
Yeah.
So 120 plus 180. This would be 300 degrees.
315, 330.
Yeah. So 300, 270 plus 45.
Hmm.
This would be 315
315,
degree, and this would be 330 degree.
330.
Any doubt in there?
No.
And of course, we have the values also, and now you will understand what this unit circle implies. Any doubt
Hmm.
in there?
No.
And we know we have already done that the 30 degree in terms of radian can be written like this, but
Hmm.
this. So
Yeah.
now this unit circle would be making sense to you. This
Yeah.
unit circle would be very important to us.
Hmm.
So slowly, once you start doing trigonometry, see, because you are not a math student, so you don't require much of remembering these. But with the help of unit circle, if any time you require the values, you will have these values. Now, just
Hmm.
remember, just remember that these are the values of cos and sine. These are the
Hmm.
values of cos and sine.
Cosine sign. Yeah.
And what we know is that if we want tan, tan would be equal to sine upon cos. Any doubt?
No.
So this is a magic circle. Any doubt here?
No.
So this is the third thing that we wanted to cover in this lecture. And this will become very important for us because in the next lecture, what we'll be doing is using these values, we'll be
Hmm.
understanding, which will be very useful, very, very useful for us in trigonometry. Using these values, we'll understand how to draw the graphs of sine and cos. Have you understood what I've said?
Yeah. Yeah.
So this is a graph. This is a graph of sine. This one is a graph of cos. So the
Hmm.
graphs of sine theta and cos theta are at the heart of something called waves.
Sorry,
And
what's your heart of?
waves. There is a concept
Waves.
waves. WAVES, waves.
Hmm.
So we'll be doing sound waves, we'll be doing light waves. Then in electricity magnetism also, in electromagnetism
Mm-hmm.
also, we'll be using this graph. So sine and cos theta, the graph of sine theta and cos theta would be one of the very, important graphs that you will see in physics and after every 4 or 5 pages. Have you understood?
Yeah.
So this unit circle will help us draw the graphs of sine theta and cos theta.
Okay.
So we will plot the angles on
Hmm.
the x-axis. I'll
Hmm.
just give you a hint so that next time you are. Actually, I had sent you 2 lectures. In the second lecture,
Yeah.
already, yeah.
Yeah. I noticed the graph is there
Yeah,
with the sine
yeah, yeah,
degree.
yeah. So if you see this x quadrant, x-axis
Hmm.
would have the angles. Do you see
Yeah.
pi by 2, pi 3, pi by 2
Yeah.
in the
Yeah.
unit circle? In the unit circle, in the unit circle,
Hmm.
basically, we'll be taking these values: the pi by 6, the pi by 4, the pi by 3, 2.
Radians we are taking.
Yes, in
Okay.
radians we'll be taking.
Okay.
So we'll plot these on the x-axis,
Hmm.
the various values. And
Hmm.
then we'll put the values of the respective sine values. So for example, sine of pi by 6, sine of pi by 4, sine of pi by 3, sine of 2 pi by 3, sine of 3 pi
Okay.
by 4, sine of 5 pi by 6. We'll be plotting the values like this, and we'll get a graph something like this.
Yeah.
So, so that is why I had asked you, if you remember, that is why I had asked you to, reduce this in terms of decimals.
Yeah.
So we'll be using this unit circle in the next lecture to
Okay.
plot the graphs of sine and cos.
Hmm. Okay.
We'll just use, a rough figure to understand the graph, but this will be very useful for us. This unit circle will lead us to the graph of sine and cos.
Hmm.
Sine and cos graphs would be useful for us because waves
Hmm.
is one of the very important topics in physics.
Yeah.
Basically, it is the heart of modern physics.
Hmm.
So we will meet waves in sound waves, we'll meet waves in simple harmonic motion, we'll meet waves in light waves, we'll meet waves in electromagnetism also, and finally in
Mm-hmm.
modern physics when we are discussing about the structure of atom, etc. Again, we'll be using the concept of waves. So
Hmm.
that is why in the beginning of the lecture I told you that this chapter and the next lecture
Hmm.
will be discussing this again and again and again.
Okay.
Now, 3 topics are covered. We come to the fourth topic, which is the trigonometric functions of negative angles. Now, this is
Hmm.
a pretty understood the logic till here. This is
Hmm.
pretty easy. Why it becomes easy? Why it becomes very easy is that if I have a unit circle like this, I'm drawing a rough figure. So if this is xy, yeah, and let me reflect this xy here. So this would be x comma y. Any doubt?
Hmm. No.
Any doubt? So this is my angle theta, and by the
Hmm.
definition of theta, this would be minus theta. Any
Hmm.
doubt?
No.
Okay. So sine theta, cos theta, tan theta,
Hmm.
and sine minus theta, cos minus theta, tan minus theta.
Hmm.
So sine theta is, let me write this as r. Yeah. So sine
Hmm.
theta is y by r,
Hmm.
cos theta is x by r,
X by
and tan theta is y
Y
by.
by X.
Yeah.
Hmm.
Now, see, one thing that you would have already observed, at the heart, this is still perpendicular upon hypotenuse. Have you understood what I said?
Yeah.
But now it is written as y by r because we are defining the angle theta in terms of the coordinates of the unit circle or any circle.
Hmm.
So now if you see here, sine of minus theta, sine of minus theta, sine of minus theta would be minus y upon r, cos of minus theta, cos of minus theta would be x upon r, tan of minus theta would be minus y upon x. Any doubt?
No.
See here, for defining this, I am using this triangle. Let me say this is OPQ. This is triangle OPQ. Yeah. And for defining the negative angles, I am using triangle OQP dash, P dash, triangle OQP dash.
Yeah.
So here everything is positive. Here everything is positive.
Yeah.
And in the minus theta triangle,
Hmm.
your x is positive,
Yeah.
but y is negative.
Yeah.
And now things become very obvious.
Hmm.
Why? They become obvious that this value minus y by r is
Hmm.
equal to minus of sine theta. Cos this
Yeah.
is equal to cos theta. This is equal to minus tan theta.
Transitive.
So this
Yeah.
is the formula that we have, that sine of minus theta is minus sine theta.
Hmm.
Cos of minus theta is cos theta.
Hmm.
And tan of minus theta is minus tan theta.
Hmm.
Again, seems to be simple, but again, very powerful three formulas. Sine of minus is minus sine theta. Cos of minus theta is cos theta. Tan of
Hmm.
minus theta is minus tan theta.
Okay.
Avantika, any doubt till here?
No.
Okay. So these are the four things that we wanted to cover. And as a homework, what you can do now.
Hmm.
Uh, okay, I'll mark this on this. I will mark this on this PDF.
Hmm.
Try to do first. Try to do the unsolved questions. Yeah.
Okay.
Example 3, example 4. Do you have this PDF or should I send you the PDF?
Um, I think I do have it. It's in my mom's phone right now.
No, no
I'll have to
problem.
check it.
I'll send it again, no problem.
Okay.
Example 8. So try to do the solved examples first.
Okay.
Yeah.
Okay.
Example 7. First try to do the solved examples. Once you
Okay.
are done with the solved example,
Hmm.
using the unit circle, I'll send you this PDF. I'll send you
Hmm.
this PDF.
Okay.
This PDF, the unit circle PDF.
Hmm.
Using this PDF, you'll have to write the values of these, the the sine, cos, tan values. Just write the sine, cos, tan values. Yeah,
Okay.
just for practice sake. That is it. That is all that I want.
Okay.
Do question number 2. Do question number 4. Question number 6. Question number 7. These are easy questions. If you have understood this lecture, you'll be
Hmm.
easily able to do this. Question number 9. Would you be able to do this?
I'll try my best.
So, uh, tomorrow we'll do the graphs of sine and cos. We'll try to understand the graphs of sine and cos.
Hmm.
If we are able to finish the sine and cos graphs,
Hmm.
then we'll move on to, okay, you can do a few questions from this miscellaneous exercise also. Once again. ठीक है पहले आप वो तो कीजिए ये बाद में देख लेंगे. This you can do as a weekend homework. So once we have done this, then we'll come to this chapter where we will be meeting these two very important formulas. The first formula is this. Again, this will be very useful for us. Cos A minus B. We'll understand. We won't do the derivation, etc. We'll just do practice questions for these four formulas. Cos A minus B, cos of A minus B, cos of A plus B, sine of A minus B,
Okay.
sine of A plus B, and tan of A plus D and tan of A minus B. If we get some time, we'll do few practice questions so that over the weekend you can do a lot of practice questions. These four formulas, these six formulas will lead us to, again they'll lead us to very important things like what is the value of cos pi by 2 minus theta, what is the value of sine pi by 2 minus theta. This you will be, you can note down, you will be using this a lot in class 11th, simple harmonic motion. In this chapter, you will be using this a lot.
Okay.
So this will be very useful. Once we are done with this, these practicing these formulas, six formulas plus the value of tan 90 minus theta, value of sine 90 minus theta. Once we are done with this, then we'll move on to vectors. So let's meet tomorrow at 11. Yeah.
Okay.
Okay.
Thank you.
Yeah. Bye.